Hello, so today we are going to talk about multi-step equations. So this is a little different than one-step equations because now we're talking about equations where you're going to have to do more steps and take more steps than you would in just a one-step equation. A lot of the ideas are similar though, so we're still going to be working with inverse operations, which are just opposite operations, and we're still going to be trying to solve um, using those same ideas, except we'll just have to do it multiple times. So let's start from the first one. So we have 3x minus 10 equal 14. So the idea behind solving equations in general is that you want your variable to be on one side and you want the answer or your solution to be on the other side. Doesn't matter which side it's on, just as long as you have variable on one side and then the solution on the other. So typically I like to, if there's a variable on one side, I try to leave that variable on that side. So since it's on the left, I want to leave it on the left side. So the thing that you have to think about now is what is attached to this x. So we know we want x to be alone. So we do have a 3x, but we have to remove the things that are furthest away and then until we can get to the closest. So the furthest thing away is the minus 10. So we have 3x minus 10. We need to get rid of this minus 10. So then the inverse operation would be addition. So we'd add 10 on both sides to get rid of it. This becomes a giant one, not a giant one, zero pair. So then you're left with 3x equals 14 plus 10 is 24. And then now we have the 3x, which remember this is 3 times x, so the inverse operation would be division. So on each side we divide by 3. This makes a giant 1. So then you're just left with x equals 24 divided by 3 equals 8. So then our final answer is x equals 8. Now you'll have certain situations where you have a variable on both sides. So it's not easy as saying, oh, variable's on the left side, so let's get everything away from the left side. Now you have a variable on both sides. My rule of thumb is I want to get the variable, I want the variable with the largest coefficient to be our winner. So like, I think of it as if you have a person, there's this big guy and you're nervous because you don't want to go after the big guy because then they'll get you. So I picked the largest number, and not just largest number, but it also has to be positive. So it is like the very, so if you look at it, you can assume this subtraction is kind of like a negative m, and then this is 2m. So if I look at these two, 2m is larger than negative m. So then I want to make sure that my variable's on the right side. So I want to get everything away from the right side. So knowing that I want this variable here, I want to get rid of this minus 12. And in order to get rid of the minus 12, I'm going to add 12 because I'm going to do the inverse. So then you end up with 18 minus m equals, this made a zero pair, to m. And then now we want the m's to be on the right side. So in order to do that, I need to get this minus m, and I need to do the inverse operation, which is adding an m on both sides. So this made a zero pair. So then you're left with 18 equals 3m. And then last bit is to divide by 3 because this is like 3 times m. So we're going to divide 18 divided by 3 equals 6, and 3m over 3 made a giant 1, so you were left with just m. So our answer 6 equals m. Okay, and then the third problem, same situation. We have 6x, we have variables on both sides, so we have 6x and just x. The 6x is larger, so I want to keep my x's on this side and move everything over. So I got minus 13. So then inverse operation would be adding 13. So then this made a zero pair. So you were just left with 6x on the left side. And then on the right side, x plus 7 plus 13, which is 20. And then like I said, I want the variable to remain on this side. So the variable that's on the right, I need to move it over to the left. In order to do that, I got to do the opposite of addition, which is subtraction. 6x minus x is 5x. And then this made a zero pair, so you were just left with 20. And then this is 5 times x, so the inverse operation would be division. So I'm dividing by 5 on both sides. This made a giant 1. You're left with x equals 20 divided by 5 equals 4. So x is equal to 4. Now we have one last problem. So this is, remember, a division problem. When you have this fraction bar, that stands for division. So this is simple. The x is already on this side, so we know we want to get everything to the right side, all of our numbers. So we got 2x over 5. So then the opposite or the inverse operation of division is multiplication. So I'm going to multiply by 5 on both sides. These 5s cancel out, so then you're just left with 2x. And then you got 6 times 5, which equals 30. And then this is 2 times x. The inverse operation would be division. So on both sides, I'm going to divide by 2. This made a giant 1. So then you're left with x equals 15. So that is how you solve multi-step equations. Obviously, the equations can get can make further and further steps. That's just the nature of solving equations. The more you add, the same rules still apply. You can still combine like terms. So say for instance, you're given extra variable, so it's like x plus 7 plus 3x. You can still combine like terms first and then solve using the same methods. But regardless, this is like the foundation of it all. Just focus on the inverse operations, working with things furthest away and working till you get to the variable and then solving from there. If you have any questions, please ask your teacher, and that is all.